quadratics. So on Monday we learned how to find the vertex, and we spent the entire day finding the vertex. We've got to do that for every quadratic that we go to graph, so we know it's either high point or it's low point. The other pieces of information that we need are x-intercepts, if they exist, and the y-intercept. So x-intercepts are the only piece that's really adding work to this. The y-intercept is very easy. For the x-intercepts, so all x-intercepts have a y value of 0. And that's not just true for quadratics. That's true in life, true in any graph that you draw. The x-intercepts always have a y value of 0. So what we're going to do then is we're just going to take the whole function and set it equal to 0. And then we're going to find our x values, and their y value is always 0. It's always the opposite value is 0. So if you need x-intercepts, y is 0. If you need y-intercepts, for all y-intercepts, you have an x value of 0. Again, that's not just true for these graphs, that's true for all of our graphs. It's always the opposite variable is 0 when you're looking for intercepts. So to find our y-intercept, you only have one of those. We're going to just put 0 in for all of our x's and evaluate. But we're going to find that there's a really easy, quick way to find our y-intercept. X-intercepts take work. Vertex takes work. Y-intercept doesn't take work. So we're going to find those three things along with whether or not our parabola opens upward or downward, and that's going to let us draw our picture. We're also going to use our axis of symmetry today to add that one more point on. And once we have all of that information, we'll be able to sketch our parabola. So the first function that we're going to graph is f of x equals x squared minus 4x minus 5. We want to find the vertex, the intercepts, whether it opens upward or downward, and sketch. And I will have this same skeleton on all of the problems that I ask you to graph. So if you get to your test and you don't remember how to do one part of this, don't skip the whole question. Do the parts that you remember to get partial credit. I count each piece as a certain amount of points. So you get points for the vertex, points for each individual intercept. So the first thing I like to do is go for my ABC, because we're going to need that for some of our formulas. So here I have a is in front of x squared, it's my positive 1. B is in front of x, negative 4. And c is my constant, negative 5. So first thing, you get a point for this. Does this open upward or downward? Upward. Why does it open upward? How do we know it opens upward? A is positive. Just look at the sign of A. Sign of A is positive, it opens upward. So we already have an idea of what our graph should look like. Parabola that opens upward. So when we find all our points, we should be able to sketch that shape through them. If they go all over the place, something's wrong with them. So the first thing we want to do is find the vertex. This is our two-step process. This is what we did on Monday. The first step requires the formula that you have to have memorized. X equals negative b over 2a. That's that front part of your quadratic formula. So if I substitute in my values, I have the negative that's in this formula and the negative on my b, so negative 4 over 2 times 1. Which gives me positive 4 over 2, or an x value of 2. So it's a two-step process. That's one of the steps. We're not ready to move on to the next section yet until we complete the second step. Where do I find the corresponding y value for my x value of 2? Substitute that number back in. Plug that number back into my function. So f of 2 is 2 squared minus 4 times 2 minus 5. 4 minus 8 minus 5. And now that I'm down to addition and subtraction, I'm just going to work left to right. So I have negative 4 minus 5, which gives me negative 9. So you should be writing these as points because they are. Vertex is a point, intercepts are points. So my vertex is at 2, negative 9. So if I go over my graph, I've got my x, I've got my y. So I go over 2 in the x direction, and then down to negative 9 in the y direction. So there's the vertex. And that's the part that we did on Monday. Are there any questions still on finding the vertex? So for x, use your formula, negative b over 2a. Take that answer, substitute it in. Now the x-intercept or x-intercepts, if they exist, that's the new part. For this, you want to set the function equal to 0. What we're doing is we're really taking f of x is the same as y. Like I said, on x-intercepts, y is 0. So we don't have y, we have f of x in our notation. So what we're really doing is making that f of x 0. We set the whole thing equal to 0 for x-intercepts. And now we have a quadratic. And it's up to you how you want to solve this quadratic. I really don't care. So from 6.6, we have factoring. I'm going to use that on a lot of these. If a is 1 and it's easy to find your pair for factoring, that is the fastest method, if it's factorable. Other options. This one would be a fine candidate for completing the square, because a is 1 and b is even. Quadratic formula works every time. If you're a creature of habit and you want to do the same thing for all of these problems, quadratic formula every time will work. But if it's factorable, that's what I tend to do just because it's the fastest. So, is this factorable? Is the next issue. Can I find a pair of numbers that multiplies to negative 5, adds to negative 4? What do you got, Ken? That'd be positive 4. Yeah, and so that'd be, the 5 has to be negative. Negative 5. So it is 5 and 1. It's just a negative 5 and a positive 1. So again, this is just one option. If you use the quadratic formula here, you're going to get the same answers. So if we solve it by factoring, you first factor it, and then you set each factor equal to 0. I would not use this method unless a equals 1. Like we'll have one later on where a doesn't equal 1. I don't even look at factoring. I just go right to the quadratic formula for that. So I got two answers. I have x equals 5, x equals negative 1. Should those two values go together as 1 point? Should that 5 and that negative 1 go together as 1 point? No, why not, Emily? Yeah, they're both x values. I can't have two x values in order to pair as x and y. So that means that this actually gave me two separate points. And what did I say before is the y value on every x-intercept? 0. And that's, again, not just true for this graph. It's true for all graphs, that x-intercepts have a y value of 0. So if I go to plot these on my x-axis, I'm not going up because my y value is 0. I have 1 point that's over at 5, 0. And then 1 point that's over at negative 1, 0. So you can already start to see where our problem might be through those. But we need one more point, 2, if you want. So the last thing we need to find is my y-intercept. You always have a y-intercept. There's only ever one. And to find your y-intercept, you let x equal 0. So what that means is if I could go by function, I just replace every x that I had with 0. So 0 squared, 0. Negative 4 times 0, 0. So what I'm left with is f of 0 equals negative 5. But you need to write this as a point. So y-intercept is a point. It's not just a value. So where does the negative 5 go in my points? The left for the x or the right for the y? Right for the y. What is the x value that I'm going to pair with this negative 5? 0. If you remember, if you think about your function notation, in the parentheses is always the x value. When you go back to your function notation, we look at f of x. So whatever number I put in there is x. Whatever number comes out on the other side is y. But you don't need to do any of this work for your y-intercept. Your y-intercept always starts with 0. This is an always situation. The x is 0. The number at the end is always c. So if you go back right to the top where we did a, b, c is negative 5. And y-intercept happens at a y value of negative 5. The reason that happens is these first two terms always have x with them. And when I substitute 0 in, they're just going to 0 out. So the only thing that's ever going to be left is c on the end. So you can look at a function and say right away what the y-intercept is. It's 0, comma, whatever c is for that problem. So if I go to plot this point on my y-axis here, I'm over 0 and then down to negative 5. So we have enough information certainly on this graph to be able to sketch the parabola. But I'm a little OCD about these things. I like it to be even. I like to have the same number of points on both sides. And if you look at our graph right now, you got an extra point over here that I don't have anything for over here. Now this is optional, but I'm going to tell you on a couple of our graphs, it's not as optional. On this graph, it certainly is optional. But we talked about on Monday that shooting out from the vertex is this vertical line. We had it as a dotted line. It always comes from the vertex. And this dotted line here is called the axis of symmetry. And what it does is if we took our paper and folded it in half on that line, our two sides of our graph would line up. So if you look at, for example, our x-intercepts. So if I start at the axis of symmetry and I count to the left to get to my first x-intercept, I go over 1, 2, 3 units and I get to my intercept. Which means if I go back to the middle, the other intercept should be 3 units to the right. So from the middle again, 1, 2, 3 units to the right. So they're symmetrical. They're both 3 units away from that center line. So what I can do with that is, since I'm missing the point on this side that lines up with my y-intercept, I just have to see how far from the center line is my y-intercept, go back to the center line, that same number of units to the right in this case. So if I look at my axis of symmetry, it takes me 2 units to get to my y-intercept. Which means if I go back to the axis of symmetry, just based on the fact that the graph's symmetrical, if I go 1, 2 units to the right, I know there's another point there. It's a free point based on the fact that this graph is symmetrical. And if you found any other point on one side, you could always count an equal number of units over to the other side and plot a point symmetric to it. Now again, in this graph, you don't necessarily need it. You'll see other graphs where we're maybe missing some points. It's very helpful to have that to get your picture. But that blue point on this graph is optional. Just gives us a little bit more to draw our parabola through. Actually, I missed it. And I don't need beautiful parabolas. All I request is that they do not come to a sharp point at the bottom. Sharp points are more of a absolute value type graph. So some sort of a U goes through those points or right by them. Questions? So there's a lot of steps to graph one of these. They're worth big points on your exam. They're worth big points on your final. But again, if they're on there, I don't know what your final looks like yet. I break it up by each individual piece. So if you get here and you can't remember how to do the x-intercept, but you can do the vertex and the y-intercept, please do those parts, plot them, get the partial credit for it. You just lose points for the part you don't do. All right, number 2. So the function we're going to graph now is f of x equals negative x squared minus 2x plus 3. So first thing I like to do is find ABC. I'm going to need that for the vertex and the y-intercept. So here I have a is equal to negative 1, b is equal to negative 2, and c is equal to 3. So does this parabola open upward or downward? This one's downward because a is negative. So we know we should get something that looks like that when we go to sketch it. The vertex is our two-step process. The first, use your formula for x. X equals negative b over 2a. So I have negative 2 over 2 times negative 1, just substituting my b and a. It's positive 2 over negative 2, negative 1. And we talked about an example like this on Monday. You have to be really careful with that negative x squared. Because when you go to substitute your negative 1 in for x, there's this negative out front that's part of the formula for our function. So this negative right here is from the function. And then with parentheses, we substitute in our negative 1 from the first part and square it. Then minus 2 times negative 1 plus 3. So the negative sign stays out front that was in our function up here. Use parentheses when you substitute your negative 1 in. And then order of operations. We've got to take care of the negative 1 squared first, which is a positive 1. But we have that negative sign that's in the function. So we're looking for the negative of x squared. So negative 1 for that first term. And negative 2 minus 1 is positive 2 plus 3. And then once you get down to this line where it's just addition, subtraction, just work left to right. So negative 1 plus 2 is 1, plus 3 is 4. So my vertex is at the point negative 1, 4. Is that going to be a maximum or minimum? Maximum. Opens downward, we have a max. So if I go on my x-axis, I'm going back to negative 1. And then up to 4. So that's going to be at the highest point on my graph. For my x-intercepts, or maybe there aren't any, we're going to set the whole function equal to 0. So what we're really doing is we're setting y equal to 0, which is f of x for us. So negative x squared minus 2x plus 3 equals 0. And then dealer's choice. I don't care how you solve these quadratics. You could factor. This one wouldn't be bad to complete the square on. I feel like that. Quadratic formula works every time. Now, when I look at this, because it is an efficiency question, when I look at this, I wouldn't try to factor it right now because a is negative 1. But this is one that I would still try to factor. How could I fix the fact that a is negative 1? I don't want negative 1. I really want a positive 1. Multiply by negative 1, or you would end up moving all 3 terms over. That would work. Yep, that'd absolutely work. As long as you did plus x squared on both sides, plus 2x, and minus 3. Move everything over. Yep, that absolutely works. Or if you divide by negative 1 or multiply by negative 1, it also changes all the signs. I'm a divide person. But yes, any three of those would get it to be a positive x squared. Now, say you did this and it still wasn't factorable. You're not really out any test time. And if you wanted to complete the square, you'd have to do that anyway. If you wanted to use the quadratic formula, it's better to have a positive. But if a is 1 or -1 and you can do a quick fix, I'd recommend looking for factoring. It doesn't take very long to look for factoring. If it's not factorable, quadratic formula. So if it's factorable, I should be able to find a pair that multiplies to -3 and adds to +2. 3 and -1. So my factors are x plus 3, x minus 1. And when you solve by factoring, write your factors and then set each factor equal to 0. So my 2x values are a -3 and a +1. But if you chose a different method, you're still going to get x equals -3, x equals +1. Yeah. What'd you get? Got 4 and 0. No, you've got to do 2 plus the square root of 16, get that answer divided by 2. Yeah, you got to do that. You got to do the numerator first, then divide by 2, and you should get these 2. So how am I going to write these as points? These don't go together. These are both x values. Emily? That's one of them. Yep, they always pair with a y value of 0 for x-intercepts. Did you get them to work, Sarah? Yeah. Okay. And did you do the same thing, Ashley? So I'm going to go plot my x-intercepts, -3, 0, and over at 1, 0. So these are all pretty close together. We can really see where our downward opening parabola is coming from. Now, for your y-intercept, there's only ever 1. We could either substitute 0 in for all of our x's in the original function, or every time you do that, it's just going to be whatever the value for c is. And for y-intercepts, we always pair with a 0 for x. So we could just do 0, look all the way back at the top where we identified c, so 0, 3. And make sure that you do these independently. Occasionally people divide by -1 and then look at this for your c. This value for c is all the way back at the top. So where I did a, b, c, this number is always the y value of your y-intercept. If you want work for that, you have to just go in and substitute 0 in for your x's. And what always happens is all that's left on there is c. So I don't necessarily need to see that work. You could just write a y-intercept down. Should be a point though. 0 first and then whatever your c value is. So my y-intercept is up at 0, 3. Again, you can really see your parabola probably through here, but I'm going to use that axis of symmetry to get myself one more point, just so it's a little bit more balanced. So the axis of symmetry is a vertical line that goes through the vertex. So my vertex is the first point that I plotted, so the blue line here is my axis of symmetry. So if you notice, my x-intercepts are spaced evenly on either side of that. One's 2 units to the left, one's 2 units to the right. So that we use the axis of symmetry to find the point symmetric to the y-intercept, since there's only one of those. So the y-intercept is 1 over to the right, which means if I go back to the axis of symmetry, there's another point that's 1 over to the left. So there's another point right here.
Do you want to always include that point?
It's good to include it. You'll see on the next two graphs, we're missing some of these points, so it's hard to draw them without it. So it's a good thing to look for. Sometimes directions do say use the axis of symmetry. I don't remember where. Maybe it's on your final review. They want the point on there. I don't require it, but you see on the next graphs we really need it to get our problem.
So is it always 1 over from the y?
Well, you always see how far your y-intercept is, and then you go that same number to the left.
Okay.
So like this is 1 over, so I go 1 over in the other direction.
Okay.
On our previous graph, your y-intercept was 2 over to the left, so we went 2 over to the right.
Okay.
So it's just the same number of units away that y-intercept is. Questions? All right, for 3, we're going to graph f of x equals negative x squared plus 4x minus 4. So let's get our a, b, and c, and always look back up here for a, b, and c. So a is in front of x squared, b is in front of x, c is our constant. This is parabola opening upward or downward? Downward. So we have a is negative. So we've got that same shape as before. Vertex is our 2-step process. First step, use your formula for x. X equals negative b over 2a. It's negative 4 over 2 times negative 1. Negative 4 over negative 2 or positive 2. And we're still working on the vertex. The second part of that 2-step process is to substitute 2 into your function. And again, be mindful here of the negative x squared. The negative doesn't go in parentheses, it's just part of the function. The number we're substituting in goes in the parentheses, which is 2. Then we have plus 4 times 2 minus 4. So when you go to evaluate this first term, order of operations says square the 2 first. And that negative sign from the function just carries down. So it's asking for the negative of 2 squared. 2 squared is 4. The negative of that is negative 4. And then plus 8 minus 4. 4 minus 4 or 0. So my vertex is going to be at 2, 0. My x and my y, so over 2, up 0. To find the x-intercept or x-intercepts, if any exist, you just set the whole function equal to 0. So I'm looking at negative x squared plus 4x minus 4. I set it equal to 0. And now you have options. This is a solve a quadratic by however you want. If a is 1 or negative 1, I usually attempt to factor it first. And if it's not factorable, jump to the quadratic formula unless you're in love with completing the square and b is even. So I wouldn't try to factor this quite yet because I have a is negative 1. How can we make a positive 1? Just divide by a negative, multiply by a negative, move everything to the other side. All of them will fix that. Again, you haven't really lost much if it's still not factorable after you make a1 positive.
So, in step 2, up in the b vertex,
Uh-huh.
where did the a go?
Negative 4 plus 8 is positive 4. So, yeah, these two together make positive.
Negative 2 squared is positive 4.
But it's not negative 2 squared. So the number from part 1 is 2.
Yeah.
When you have the negative in your function, it's on the outside of whatever you square. So for x-intercepts, we set the whole thing equal to 0. If a is 1 or negative 1, if it's negative 1, I'd fix it, see if it's factorable. Or, again, you can go right to the quadratic formula if you want. If you want to complete the square, you still need this step here. So can we come up with a pair that multiplies to 4, adds to negative 4? Negative 2, negative 2. So this one is factorable. And this is the quickest method if you're good with your shortcut factoring. So how many x-intercepts am I going to get? Just 1. Because when I get the same factor twice, I mean, you could set the same factor equal to 0 twice, but you're not going to get anything new out of that. So you don't really need this second one. So it's the same thing. It's going to give you the same value for x. It's going to give us x equal to 2. Now for x-intercepts, what is the y value that I pair with them? 0. That was kind of a bust. We already have that point. We got that point up here. So we don't have anything else we can add to our graph. What's that? The y, but yes, up to this point we don't. The only other thing we have is the y-intercept, and this is a graph where we're going to really want to use that point that's symmetric so we have some idea of where the other side of the graph goes. So there's only one x-intercept here. It also happens to be our vertex. If you have only one x-intercept, it is always your vertex. And you can find that by your vertex has y value 0. So what's my y-intercept for this graph? What do you say, Sarah? 0, negative 4. Yep, make sure you have it as a point. Your x value is 0. This value right here is just your c from above. So whatever c is goes in your pair for your y-intercept. So my y-intercept is at 0, negative 4. And we don't really see much of a parabola there, but we know it's a parabola because we're graphing a quadratic. If you draw a straight line, it doesn't work. It's not a straight line. So this is another case where, remember, this axis of symmetry always comes from your vertex.
So will C always be your y-intercept?
Yes. Yep, because if you plug 0 in, these first two will always go like 7x. Yep, it's always just C. So if I want another point so I get a better idea of my parabola, if I go to my axis of symmetry, count how far over the y-intercept is. So it's 1, 2 to the left, which means if I go back to that axis of symmetry, I know I have another point, 1, 2 to the right. So it's the same number of units away, just on the other side. And that just gives me one more point that I can go up and connect with to draw my parabola. Now in this last example, I apologize, I never remember to put a different grid on it. Our graph doesn't actually fit on the 10 by 10 grid. Because what's our y-intercept for this graph? 0, 11, so it doesn't fit on a 10 by 10. So we're going to use our imaginations and draw one more line above 10. But first, let's open upward or downward. So let me get my A, B, and C. So A is 2, B is negative 8, C is 11. Upward or downward? Upward. So we already have an idea of our picture. The vertex is our two-step process. First, we find x for negative b over 2a. It's negative 8 over 2 times 2. 8 over 4, which gives us 2. And then the second step is to substitute that back in for x. So we're looking for f of 2. It's 2 times 2 squared minus 8 times 2 plus 11. Order of operations, make sure you square first. So 2 times 2 squared is 2 times 4. You have minus 16 plus 11 is 8 minus 16 plus 11. 3. So 8 minus 16 is negative 8 plus 11 equals 3. So my vertex is at the point 2, 3.
You can just do it on the calculator. You don't need all that work.
I'd like to see you set it up. Like, show me what you substituted, where your parentheses are. But yeah, you could enter that all in the calculator. So I'm going to go over to up 3. Here's my vertex. Now, for your x-intercepts, when you set the whole function equal to 0 here, I wouldn't even waste your time trying to factor. A is not 1. I wouldn't waste your time completing the square, because to complete the square, you've got to get a to 1, so you'd have to divide them all by 2, and then you'd have a fraction here. Still not great. So when in doubt, quadratic formula solves them all. So I'm going to use the quadratic formula on this one. I wouldn't even waste my time trying to factor because a is not 1. So that's your x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So when I substitute in my a, b, and c, which I have listed at the top, or I could get them from here, negative 8 plus or minus the square root, negative 8 squared minus 4 times 2 times 11, all over 2 times 2. Gives me 8 plus or minus the square root, 64 minus 88 over 4, which gives me 8 plus or minus the square root of negative 24 over 4. Now, when you're working with the quadratic formula, what's the first thing you always simplify? The radical. So this is something you'll need to know for your quiz on Friday. You always simplify the radical first. Well, what's going to happen if I simplify the square root of negative 24? It's imaginary. You're going to get an I there. We can't graph imaginary numbers on this plane. This is a real plane. So this is imaginary, which for us in this particular problem lets us know that there are no x-intercepts. And let's just think about it conceptually. My graph opens upward. So is my vertex a maximum or a minimum? Minimum. Look at where my vertex is. This is the bottom of my graph, which means I've got some sort of parabola coming down and turning around at that point. Where does it never get to? The x-axis. The graph is shifted up higher than that. So this is a case where you have no x-intercepts. It just never gets that low. It turns around and goes back up before it reaches the y-axis. And, the x-axis. Emily?
So whenever there's a negative underneath the square root,
You
you can't do anything?
can't do anything.
You can't make it an I or anything?
If it were just a problem of solve, you would make it an I. But in terms of finding an intercept, it's not real, so we don't have one. Question?
So you can tell there's no x-intercepts in your vertex if you know your thing's opening upward and your vertex is above the...
Yes. Or if it's opening downward and your vertex is down here, because then it's going to come up again, never reach it.
But you
Yes.
don't want us to do that.
No, I don't. If you can see it conceptually and you just can write me a little ditty,
Okay.
and like graph never gets to the x-intercept, fine with that. And then our y-intercept is up at 11, and I got to plot this quick because we're at the end of our time. Again, we're going to use our imaginations, put 11 up here. And this would be another good candidate, since there's only 2 points, to use that axis of symmetry to draw yourself one more point. So again, you have 3 of these to try. These are big point questions because there's a lot of work with them. Also on Friday is your quick quiz. All of that practice material is on Blackboard.